So this is a project we've been working on for quite a while, and has gone through a number of revisions. And this is joined with the I mentioned this, besides myself, is Flavio Cunha from Rice, and Pamela Jervis, who's now at the University of Chile. So this is my overall outline. Hopefully I will be able to go through this in 40 minutes. Let me start with some introduction and background. You know, as I don't need to convince you that there is now a substantial body of research that points to the fact that the development of human capital in the early parts of life is very important. And those are just some of the papers that have been looking at this issue, both in developed and in developing countries. At the same time, while there's a substantial and growing amount of work devoted to these things, it's clear that what we economists call human capital, its formation is a very complex process. We come to realize that human capital is a multidimensional object. There are, lots of aspects to it that matter, both in economic activity, and they get remunerated differently. One of the papers today was talking about this in the labor market and in the process of formation itself. So cognitive and non-cognitive skills, as well as health, may matter quite substantially. We know that skill formation is a dynamic process. Jim Ekman has been talking quite a bit about dynamic complementarities, including yesterday. And so these different dimensions of human capital, both within and across fields, play an important role. There are still lots of open questions. We still need to know much more about the details through which human capital develops. We need to understand better its persistence over time, and what role different different inputs in the production function of human capital play, and how these roles change over time. And a good understanding of these properties then is crucial to for the design of policies that we might think are necessary to improve and to remedy some of the early deficiencies that we observe. In all this, one thing that is very important is to understand, especially for the first 2 or 3 years of life, is to understand how parents behave and what kind of factors determine parental investment. Now, the goal of this paper is, in the long run at least, is to understand parental behavior. Now, even in the simplest model you can write down, parental investment will depend on the resources they have. If they can send their kids to a nursery or not, whether they're working or not, how much money they have, etc. Depends on their preferences, and that can be quite complex. It's not just how much they love their kids, but it could be driven by other factors as well. And crucially, and that's going to be the essence of these papers, it depends on what they think the production of human capital, about the production of human capital, about the process that generates development. So if you observe that they invest not a lot, for instance, in terms of the time they spend with their kids, it could be driven because it could be explained because they don't love them, or it could be simply explained by the fact that they don't think it's particularly important. Now, we know from a lot of literature, both in child development and in other fields in psychology, that the parental inputs of time and materials are very important for the process of development. But it's not clear that the parents have a good understanding of that process. To use our jargon, do parents know the production function? So what motivated at least me, and I'm sure some of my co-authors, to go into this project, So a few years ago, we ran a large randomized controlled trial of a parenting stimulation program in Colombia. This is I will say a few words about that. It's very similar to the intervention to the one that Jim talked about that they've been doing in China. And so as we'll see, that parenting stimulation program had some impacts on a variety of outcomes. And those results were published in a paper that was in the journal, in the British Medical Journal in 2013. Once we got the results from comparing means in the various outcomes between the treatment and control groups, the next step in the research, our research agenda, was to understand how those outcomes were achieved. So we estimated the production function for child development, and this is the true production function. It's not what parents believe. And indeed, one of the points that we make is that we do this in a way that we don't require, we take into account the endogeneity of parental investment, trying to establish the role that various inputs play, but we don't need to assume that parents know the production function. Moreover, because we want to understand where the results of the simulation comes from, we do not use the RCT as an instrument for parental investment. Indeed, one of the hypotheses that we wanted to try as a second step was, did the intervention have a role on its own, or did it have a role by changing parental behavior? And that paper concludes that, as we'll see, that the role was through changing parental investment, and is now published in the AER. What are the main results that we get from that investment? The summary is that the technology of skill formation is well approximated by Cobb-Douglas. And I list these things because these are going to be, we're using the same, in the paper on beliefs that I will be presenting today, we'll use the same data from that experiment. And so those are going to be relevant. So the technology seems to be well approximated by Cobb-Douglas specification, where the main inputs are parental investment in initial conditions, where the children start from. The parameters don't seem to be affected by the intervention. So we don't change, say, the productivity of parental investment. Human capital at the beginning of the period matters. And parental investment matters a lot, and especially so when you allow for endogeneity of parental investment. When you run an OLS of the log linear approximation, you find a certain coefficient, and then once you take into account endogeneity, that coefficient goes up a lot, which seems to be indicating that parents the parents do some sort of compensating strategy for their investment strategy. Interestingly, parental background, which we do not use as an instrument, but parental background seems to have an effect mainly through parental investment. Once you control properly for parental investment, then there is no effect of, say, mother or father education in child development. An important point, which is relevant for the work today, is the program seems to shift a lot the distribution of parental investment. And instead does not seem to have direct effect on child development. So it's not, the program, as we'll see, is similar to what Jim was talking about yesterday in China. Is is a visitor that goes once a week and interacts with the child, with the caregiver and the child, an hour a week. So it's not that exposure that seems to generate the results that we get. And so the results indicated that the impact was explained almost exclusively by an increase in parental investment. And so the next question, so this was the AER paper. The next question we ask is, why did parents increase investment? We don't give them anything. We don't give them money. We just give them these weekly visits in which, as Jim put it yesterday, the visitor is supposed to teach the child development specialists would hate that terminology, but it's supposed to teach how to do proper parenting to the parents by showing how things are done, by interacting with the child and the mother, or the child and the caregiver. So it could be that maybe makes it realize and change their perception of the technology of skill formation. So how do we address that problem? This question came to us after we did the evaluation. So we went back there and we decided that we wanted to elicit information about the parental beliefs about the process of child development directly. This is some work that Flavio had already done in Philadelphia with one intervention he was doing with disadvantaged mothers. So we joined force with Flavio, and we decided that. So in this contribution, effectively, I would say that we do two new things. First, we propose what I think is an innovative methodology to elicit subjective beliefs about the process of child development, and you use a measurement system. You know, Jim has been using that a lot. This morning, Eric was using the measurement system explicitly. So we use that structure, and I'll make it clear how we use the measurement system to design the questionnaire to elicit parental beliefs. And then we use the beliefs data to estimate first directly perceived returns to certain types of investment, but more generally to estimate the subjective production function of human capital, how parents perceive this production function to be, and then we can compare it to the objective production function. So more specifically, we decided in the new survey that we did like a few years after the end of the intervention, we designed a module that elicited parental subjective beliefs about the process of child development. And so in this presentation, I will first describe the elicitation survey instrument. Then I will show how to estimate the subjective expected return to parental investment in a very coarse way, and analyze how there's cross-sectional variation of subjective expected return. Then we'll play some magic and use this data, these questions, to derive from them the perceived production function. So the assumption there is parents have the same approximation of the production function that we use, but they might have the wrong parameters. And so if we do that, how do we unravel, how do we estimate the parameters that each respondent gives us? And then once we have that, we can compare this distribution of parameters for the perceived production function to the true parameters of the production function. And as we'll see, there are a number of issues. Again, Jim mentioned quite a few of them already. About how do we do about anchoring, the metric that we use for this, all this latent factors is going to be important. And then what we do, the final thing is we relay, once we have this stated, elicited beliefs, we relate those to actual behavior, to parental investment. And so we check whether they associate with the parental investment. Do parents that believe that the investment is productive, do they actually invest more in their children? So that's the point that I wanted to stress is that without the data on beliefs, we cannot distinguish between different hypotheses to explain the changes we observe in the investment behavior. Okay, so that's an introduction. So let me go very quickly through the conceptual framework because it's pretty.
So maybe that's a good point.
Standard.
Orazio? Maybe yes. It's going to come in with a question from John.
Yeah.
Namely, whether the change in parental investment could in part be a Hawthorne effect, quote unquote, So is there any way to test for the possibility that the knowledge they were studied caused parents, that they were being studied caused parents to look more exemplary, but after the study, they returned back to the same old?
Yeah, that's a very good question. As I mentioned a couple of times in passing, we collected this data very late. In that, we collected like 3 or 4 years after the interventions was finished. Moreover, in the second follow-up, we found that while in the first follow-up, at the end of the interventions, parents had shifted their investment behavior considerably, remarkably. This change disappeared after a few years. So we cannot really address John's questions. With this data, what we can do is to show whether parents with higher perceptions relate to invest more. Having said that, I was when I started preparing this lecture, I thought we've been now doing a big project in India. And there, because this project was done after the Colombian one, we collected this beliefs data throughout. We collected a baseline, a midline, and an endline. And so then we can study how beliefs change over time and whether they're directly, because they are simultaneously in part of the sample with the intervention, we can test all those hypotheses. But this data, we're just starting to analyze them. So I don't, I hide a few tables on that, but I decided to drop them because already, as you can see, I have 65 slides and 40 minutes. So that was not feasible. But hopefully in the future, I will be able to address that question better. So the evidence from parenting simulation programs indicating parents, especially vulnerable parents, disadvantaged households, invest too little. And this is consistent with some anecdotal evidence. The 2 great books that I strongly advise, they are both based in the US. One is Annette Leroux, who is an anthropologist. She wrote a few years back this book, Unequal Childhoods. Now, it's a great book and talks about, she has this concept of, middle-class parents do what she calls concerted cultivations. So the parents take their children to soccer practice and to violin lessons, and they teach them how to interact with authority, and so on and so forth. Poor and the working class families, they pursue what they do is she says, they pursue this idea that natural growth, development just happens naturally. So let the kid be, and they will be okay. So those are different, completely different ideas. Now, she's an anthropologist, so there are 12 chapters in that book, and there are 12 children that are being studied. Nonetheless, so there is no statistical analysis for some side. Nonetheless, it's a very, very informative and illuminating book. And some of these ideas were taken again by Robert Putnam in his 2015 books, Our Kids. Now, in economic, if you write down a simple economic model, in the standard model, the determinant of parental investment are financial and material resources, preferences, and beliefs about the technology or skill formation. And so investment behavior, if you look at, if you have data on what parents do, they can be informative both about information and both about preferences and parental beliefs. Now, it's very hard in general to disentangle these 2 different effects without further assumptions about information. Now, people often assume that parents know the true production function. And if you're willing to make that assumption and a few other restrictions, then you can estimate the production function, and then you can use the investment data to disentangle the preferences parameters. However, if you don't want to assume that, if you want to, as in the last point here, if we want to measure what parents believe about the productivity of investment, then you need to do something more. So what we do in this paper is to elicit beliefs directly. So I'm not really doing badly. So let me skip the model is pretty standard. There are preferences that depend on consumption and human capital of the kids. We also have the possibility that parents receive utility from or this utility from spending time with their kids. There's a budget constraint, and there is a true technology of skill formation. We use the specification is translog. Special cases the Cobb-Douglas when delta 3 there is 0, so H0 is the initial condition, XI is investment, and which has a price P, and the H1 is the final level. And so that, then we relax the assumption that parents know. We assume that when we go through the process of converting our data into subjective production function, we assume that the parents use the same functional form, but they might get the wrong parameters. So each parent has got this assumption here. So instead of the delta, we have this mu's, and notice that there is an I index on the mu's that might reflect parent I ideas. So then there is a maximization problem, and there is an investment function. So let me skip that. Now, how do we do to elicit these beliefs? Obviously, you cannot go to a respondent and say, what are the parameters of the Cobb-Douglas or the translog production function? So the basic idea, let me just say it in words in case I have to skip again on slides, is to, a production function is a mapping that goes from X and H0 to H1. And so what we do, we provide the parents in the questionnaire with scenarios. We say, okay, consider a child which has H0 and considering parents that gives X. And so we we propose 4 different combinations of H and X. And then we ask the mother, what do you think H1 is going to be? So, the function is a mapping from a domain to a codomain, and we choose 4 points of the domain, and we ask what is going to be the codomain. Now, that's easier said than done. And what do we do in practice? Well, we try to use data to do this effectively. When we did the RCT, we had lots of information, both on child development and on parental investment. The intervention was very similar to the Reach Up curriculum. We adapted it to Colombia, and the aim was to improve different dimensions of child development. We had 1,400 kids at the beginning. At the beginning of the intervention were aged between 12 and 24 mothers and lived in different 96 towns. The randomization was done across towns for the RCT. We then collect data, baseline and endline, on different modules of household module. And then we have both child assessment, the Baileys, and the maternal report on child development, using essentially a language. Does your kid say this word, etc. We also have data on parental investment and intake of micronutrients.
There was just another question, whether you also have data on younger siblings, and that might help you potentially get around some of the issues John mentioned.
There are not very many younger siblings, especially at the beginning, especially when we collect this. These were children aged between 12 and 24 at baseline. Quite a few of them had older siblings, but obviously when we go back with the expectations data, we do have younger siblings, but we haven't collected specific data on them for budgetary reasons. So in terms of the initial conditions, we use two big instruments. One is the Bailey, which is a long and complex test which assesses the child. So it takes about 90 minutes, and it has to be administered by specialized psychologist that assesses the child. Language scale, which is language inventory, which is about 100 questions that are asked to the mother. And it's basically a list of words, and the mother asks, does your child say or understand this word, and you go, here it is. In follow-up one, we collected, again, similar data. We got, again, the Baileys and the MacArthur, and we get the family care indicators to measure, is a standardized test to measure time investment, parental investment. And in follow-up two, which is when we did the belief elicitation, was done 2 years after the end of the program. And this is what I was saying. In order to relate observed variables to abstract contracts that enter the equation, such as the production function, we use a standard latent variable model. And so we have these latent unobservable factors, and we call them child development at age 1 and child development at age 0 and parental investment. And we have lots of markers that relate to that. And so then we estimate the measurement system and estimate it to summarize all this information, all this data to the latent factors. That's the standard practice in this literature. That's what Eric was doing, and with his co-authors, that's what Jim has been doing in many contexts and the like. What we do, however, is something more. So we take the estimated measurement system, and we use it to construct hypothetical scenarios to elicit subjective beliefs. To be more precise, so implicitly assume that the mothers share the same measurement system, which means they relate child development to certain markers. So as I mentioned, we have the Baileys and we have the MacArthur. The MacArthur is a bunch of words that we ask the mothers. So we estimate the measurement system for all this. Then we pick a few words that seem to be particularly salient to represent child development. And we tell the mother, think of a child, not your child, but an hypothetical child, that at age 12 months or 9 months can say this set of words. Now, suppose that the parents of this child can do with that child this set of activities. And again, we choose the set of activities from the FCI, the family care instrument, so that they are salient and important and informative markers of parental investment. And then we say, at what age do you think your child, this hypothetical child, will say this other set of words? And again, those words are chosen from the MacArthur to be particularly salient. So this is the measuring system, but because I'm running out of time, I'm trying to rush through this. This is the specifics of the measurement system. And so for each scenario, we have high initial development and low initial development, high parental investment, low parental investment. We ask several questions so that we can obtain different measures of the mapping from the scenarios to the outcomes. Why do we need several measures? Well, because there is measurement error in this stuff. So we not want to be able to average out this stuff. So these are the 4 scenarios which I described in words. We discussed a lot whether we would use their own child or a hypothetical 9-month child. We went for the latter because for a number of reasons. We don't want them to self-justify what they've done. We want them to think of an average child. We also want to take into account that they are aware of the fact there are many other factors that affect child behavior or child development. Although we're interested in this particular mapping in production function, so we want them to consider some sort of average hypothetical child that differs only in these 4 scenarios. So we identify salient words and salient items of the SCI. And that's what we do. Once we reduce this is the curve here is in our baseline and endline data on the children of this 9 months age, the estimated distribution of the cognitive development of those children. Now, if you then take the scenarios that describe to the mother a low development child, so imagine this child can say this word, this word, this word, but cannot say this word, this word, this word. Then you can use the parameter of the measurement system to infer the level of development of that child, and that's this straight line here. For a high development child, it's this straight line here. You do the same thing for a parental investment. This is the latent factor of parental investment, the distribution. This is the description of parental investment in the low level case. This is high level case. So the combination of these these 4 points of the domain are the 4 scenarios, and then we relate it to the outcomes. Now, in all this, we describe quite a lot of visual cues. For instance, these are the VICMEC that we use for the low and high parental investment. This is a low investment. This poor kid only got a ball and a teddy bear, nothing else. The high investment, he gets all this stuff, and the mother does all sorts of things with the kid. And so these are quite useful. And as I mentioned, then we construct 3 sets of words for the outcomes. So what we call easy, medium, and difficult words. And so we can get different measures of the mapping. And so that is going to be crucial to be able to estimate the subjective production function. And again, we use those words to be particularly salient using the later on the MacArthur survey. So we use tablets to elicit this data, and these are tablets. So these are the line here. We say this is a low initial condition, low investment, low initial condition, high investment, high initial condition, low investment, high initial condition, investment. And then each of the 3 is easy, medium, and difficult word. And then the lines is at what age your 9 months old will be able to say these easy words under this scenario, and then again under this scenario. So this is the way it's done. 2 important things I need to stress is that before doing this, we train them with this idea of using these tablets, these physical tablets, by giving them different examples, like when does a child start to walk and run and crawl, and different nutritional outcomes. And the interviewer is instructed to correct them during this training phase. Once they go to do this, we instruct the interviewer, once they are completed the 12 little beat there, they say, okay, these are your answers. Do you want to revise them? But they are instructed not to correct them. in any way. So there could be inconsistency. It could be a child that first learns to say heteroskedasticity and then learns to say mother. But so that's during the practice. One of the ladies doing it, and again, and so those are the descriptive data. So this is the averages in our sample. This is a low initial condition, low investment. This is the easy, medium, and hard. This is the average age of which they say. So they line up pretty nicely. Already from this data, we can compute returns because if you compute high investment minus low investment, is the return in months, if you wish, and for a low initial condition and for a high initial condition. If you average across the set of words, that's the sort of things that you get. And what you find is that, and this is a very strong finding, we find it now in India, we find it repeatedly in this type of populations. These ladies seem to be thinking that the investment is more productive when the child is at the low level of development. So if he's a problematic child, investment is more. If you estimate the production function, this is wrong. The complementarity is positive, it's not negative. But they do think that the investment is more productive for low investment, for low initial condition kids, the high investment condition. So that's the first finding. Now this is very simple. That's the first set of results. Then the second set of results, how much it's horrible because we try to use this stuff to estimate subjective production function. This is a bit complicated and is substantially boring in the sense that one has to sort out location, scaling, and of the measuring system. The issue there, these are latent factors. You need to choose carefully the way you scale things if you want to compare the actual data with the parental investment. So we need to do a bunch of things. You'll find them in the paper, but let me skip through this. Once we do this and we do these factors, we convert the questions that the mothers do in factors, then we can estimate, we can have data that we can use in the in estimating a subjective production function. Now, this subjective production function effectively have 12 observations per person. So we have the 4 data points for the domain, and for each of those, the 3 easy, medium, and difficult work. So 4 times 3 is 12. We have 12 data points. So we can estimate those regressions with for each mother effectively with 12 data points. It's a bit more sophisticated than that, but that's what it is effectively. And then we can use the standard approach to estimate the objective production function. We can compare them. So let me, I'm sorry to go so quickly through this. This is the location stuff. And then let me skip this. This is how we use the SWAMI estimator to estimate the means for each mother. So it's a bit more efficient than OLS using those 12 observations per each mother. At that point, we have estimates for the means and we have estimates for the deltas. The means are 1 per mother, and the delta are. So these are, first of all, in terms of returns, the picture is similar to the one with the months. This in terms of developmental age, this latent factor we have. And then we relate these returns to observables. This was remarkable because effectively the most robust result is that the mother IQ, we do in the second follow-up, we do a Raven's scores on the mothers, which is some sort of measure of IQ, and they seem to be positively correlated with with the return for the high initial conditions. But other than that, we don't find much else that determines, including our treatment. The treated mothers don't, 3 years after the intervention, don't seem to be different. And then this is how we estimate the effective, the objective production function. And this is what we get. This is the Cobb-Douglas, and this is the translog for the objective production function. I should mention that once we do instruments, this coefficient is much, much higher. The translog has got some evidence here, some interactions, and this is the productivity. You know, the translog's parameters, because of this interaction, are a bit hard to interpret, but this is the how the production function changes at different percentile of initial conditions with the investment. So there are some interactions, and there are positive interactions. This is what I was saying, that the mothers are actually wrong in thinking the investment is more productive for low initial conditions and high initial. This is the opposite in this graph. And then when we do the subjective production functions, these are means in the sample. So we have an intercept, a human capital coefficient, an investment coefficient, and their interactions. This is the Cobb-Douglas, this is the translog, and that's what we get. Now, if we compare them to the deltas, we find that if you assume Cobb-Douglas in both cases, then the average mu1, which is the coefficient on initial conditions, is very similar to the actual one, but the mu2, which is the coefficient on the investment, is much lower. It's half. It's 12 instead of 24. When you do the translog, again, there are some big differences between the average that mothers think and the actual numbers. And you can see that you know, they are very. Notice how the change flip. That's what I'm saying. They got the completely wrong idea on average about the complementarity between initial conditions and investment. So these are how we relate these estimates of the mu's to various observable. Again, what seems to be important is the raven is the only significant variable, and this is in translog. And that's my last table, last two tables, one of follow-up 1 and one of follow-up 2. How does real investment, what actually parents do, relate to these estimated production functions? And you can see that, you know, for the mu2 and mu3, they are important. Since this is the log of the total investment factor, they seem to be determined by the productivity of investment. So that's, you know, this tells me that these beliefs data, they're actually useful. They're not crazy answers, because they do relate. And those were collected 2 years after this investment data. They do relate to what parents actually do. In the follow-up 2, we also do investment. Again, there is some relationship, especially for the mu2 to actual invest. These are the total factor of investment. This is time, activities, and materials, the 3 subscale of investment. So let me conclude. I'm a little bit late. So we have listed parental beliefs about the production function. We've shown that they how to relate answers about the potential age and the different scenarios to beliefs about the returns to investment and the parameters of the production function. And then we find what parents think about the productivity of investment does relate with the investment. And let me stop here. You know, you might have not. I think one of the novelties in this paper is the fact that we go out and elicit this belief data. And this is going to be the fact that we collect this data on, these are not revealed preferences data. These are data that are collected, presenting subjects with hypotheticals and with stated statements, which is not the tradition in much economics. And that's going to be the main theme of my lecture tomorrow morning. And I'll stop here.
Great, thank you. Wonderful and amazing how you made it through 65 slides. And
I cheated. I skipped quite a few.
Maybe it's too late for me, or the days have been too long. I didn't quite get on the last table that you showed how that related to where kids are in the production functions that you elicited. So is there any mapping sort of looking at, okay, my kid has...
So what this regression does, and incidentally, Flavio and Pamela didn't want to present this table because we don't know, when we do this, we do not take into account these mu's are generated, our data are estimated. So there is some measurement error here. And we are working towards producing a version that corrects for the use of the generated data there. But if you believe this data, what we do is the mu1 is the coefficient on initial condition. The mu2 is the coefficient on investment, and mu3 on their interaction. So these are the parameters for each individual mother, the parameters of her own production function, the perceived production function. Then what we do is we relate, this is the actual investment. This table is for the baseline, for the first follow-up. So we relate actual investment to these perceived productivities. Now, we need to put some graphs because the interpretation, again, you know, when we did the actual thing here, we did the graph because the translog is not easy to interpret because of the interaction. So we left to do the graphs. But what the table is saying is that parental behavior seems to be driven in an important way by their perception of the production function.
Great, thanks. So Andrew, I had another question. We'll just walk over.
First of all, very interesting stuff. I was sort of interested in how this interplays with the model that Professor Hegman presented yesterday. If you think he was trying to disentangle this ability to learn with the level of skills that often sort of determine how long it would take for someone to reach a new mastery level. So if you think about it, here people are basically posed with an experiment where you give them an initial mastery level, and then you elicit beliefs about the productivity of investments. That would seem to depend on the assumption of the ability to learn that Professor Heckman mentioned. And in particular, I guess I wonder if households might apply their own priorities about the ability to learn, because a lot of times even if we give a hypothetical to a person, they often sort of implicitly assume their own circumstances. So I wonder if part of this could be heterogeneity in these beliefs about the ability to learn that Professor Hegman was talking about.
So in terms of the specification, first of all, I cannot see who you are from a distance. So I don't, but anyway, it doesn't matter too much. But this is a good question. I guess the specification of the reduction function, you can think of what we wrote here and try to translate it in terms of Jim's equations yesterday. We do have that the level of development depends on the initial condition, and you can have more complex specifications, possibly introducing different dimensions of human capital, which is incidentally is what stuff that we're trying to do in India, where we do different dimensions and the like. Here, what we had in mind is the specification that I wrote, and you can enrich that. But I guess the important point I want to stress again is given that model, then we find that parental investment, even before, well, a few years before we asked those questions, that's related to the perceived productivity that these people have. Now, when we design the question and when we pose them the question, we stress repeatedly that this is not their own case. And I was mentioning that. First of all, this was the question relates to children that are 9 months old, and then there is a period. This was like at least the target child. They might have a new child, but at least that target child was 9 months old 3 years before the question was. But the stress was exactly to avoid that kind of problems that you seem to suggest. The stress in the questionnaire is that they should think about a hypothetical child with this feature. In a sense, the moment you start changing the scenarios, because at first you say, imagine a child that can, at age 9 months, can say this set of words. Now imagine a different child, which at the same age, can say this other set of words, if this is a bigger set. And then again, for these two children, imagine the parents this other. So, we thought that putting them with an hypothetical child that rather than their own child was easier to change the scenarios, which is what we want to do to identify the production function to post the hypotheticals.
Right, great. Let me hand over to Joe for one last question.
Hi, Orazio. Thanks for this talk. It was I love seeing this research. It's really interesting. I was looking to get some help in interpreting these regression coefficients. Do you know, in terms of explaining overall variation in investments, how do the beliefs compare, say, to wealth? Or I'm not sure if wealth explains much variation either, but it would just be interesting to know.
That's a very good question. I don't know the answer to that, but I know the data a bit, and you can look at the R squares of these regressions. These regressions, they do have some background variables. For instance, there is household wealth there in that regression. If you look at the last line, and so you can see that when you put everything. Still, you get an R square of 12 or something like in the second column, but those are significant even on top of that. The one that changes things quite a bit is the mother's IQ. If you compare column 1 and 2, the coefficients drop quite a bit. If you remember, mother's IQ was one of the few things that was related to those perceptions. So that's why we are now investigating whether we should correct for measurement error here, which is not done in this particular table.
Right. Would it be, because you have to estimate an investment equation to estimate technology also, right? Or do you not need that in this approach?
Absolutely, and that's what we do. in the, let me see, there is a, yeah, this table here, this is the objective production function, and this one with the control function, where the control function uses, in this particular case, given what we find in the AR paper. The AR paper, we find that the intervention, a follow-up one, does not affect child development. So here we use it as an instrument for simplicity. And so that when we compute the control function, we use that as an instrument. And you can see that the sign is negative in this compensating behavior I was referring to.
Yes. Okay. Well, yeah. Very interesting. Thanks for your answer to that.
Yeah, but you're right. I mean, it might be useful to compare the investment equation that we use as a first stage. I don't have it in the slides.
Yeah, that's what I was thinking. But yeah.
Excellent. So thank you very much for this inspiring talk. Thanks everyone who spoke at the conference. I found it overwhelming how many interesting papers through such a wide variety of topics on life cycle models, capital, etc. we saw. So let's give all speakers one last big hand.